We're now working in the Fundamental 6 continuity project, and in this file here I've brought in a canvas image of Mike's final design, because I want to use his revised side window outline as an example for the curved fillet. Now when you're working with canvas images, it helps if you use the transparency sliders to tone down the intensity of the image so that you can see the curves. And over here I've already created the main curve shapes with this new angle at the rear. So let's have a look at the curve fillets. And here on Curve Edit, on the first menu, there are two fillet tools. An older tool called Fillet Curve and a new one in version 2015 called Curve Fillet. And I'll start with the old tool. So I pick one curve, then the other. I get the default of 100 and I'll just change that to 60. And then hit Accept. And what that's done is created a degree 3 single span, which allows for position and tangent on this side, and then position and tangent here. So it looks okay, but the fixed radius gives a rather abrupt transition that doesn't look quite right. Also, it's only worked because all these curves are in the same flat plane, whereas these curves over here have got shape and curvature in 3D space. So if I were to try to use the same tool to do, say, this large blend here, then I get a message that says fillet failed to construct. So here's where the new Curve Fillet tool can help. But just before I use that, I want to use the Curve Curvature Locator on these curves, because it helps to understand continuity. And I'll just turn off the canvas plane to make it easier to see. So these two curves come together and meet at a sharp point. So that's G0 position continuity. And that's shown by this angle break between the cone plots. So what happens if I now go for tangency? So I'll set the new Curve Fillet tool to a circular fillet. And this is much bigger, so I'll set that to around 1200. And then I pick one curve and then the other, just like before, and say Build. And I've got a trim type option here, which I'd normally set to automatic, so that it'll trim the main curves back. So that's done the same as before. I've got just a degree 3 single span. So I've got a position, tangent, and position and tangent. So if we take a look at the curvature plot on that, then you can see that at the join the two cone plots are aligned in the same direction. But the radius values are very different. So I can use the radius locator and I'll just pull that to the end, and that one's about 1200. And then for this one I'll need to use Move Locator to bring it down so we can see it more easily. So this curve's around about radius 6000, and it suddenly goes into this curve, which is around about 1200. So it's that sudden change in radius that makes the tangent fillet look abrupt. But another advantage of the new Curve Fillet tool is that we can adjust the continuity. So if I now switch to G2 curvature and then update, with G2 the radius values are now matched at the join, which takes away that sudden change, and it now eases into the blend. And it's done that by adding some extra CVs. So we've now got a position, tangent and curvature CV, and position, tangent, curvature on this side. So I can go further and choose G3 curvature and update again. And now it's added in two extra CVs, which allow for this softer lead-in, and that makes the transition almost imperceptible. So we've got 1, 2, 3 for curvature, and then a fourth CV for G3, and 1, 2, 3, 4 on this side. So the continuity setting is the main determinant of the shape, but we do have some flexibility with this form factor slider here. And if I reduce that down, then it pushes the CVs towards the center to make the curve sharper. And if I go the other way, then it pulls the CVs back, which makes it flatter and more like a circular fillet. But a value of 1 will give the most even distribution of CVs. So if I delete those locators and turn off the CVs, you'll see that we've got a really smooth result. So let's see if we can use this tool to improve what's going on here. So I'll just template this one to use as a comparison, and I'll extend these ones back a bit, and I'm fine to lose the history. Now the fillet tools don't mind if there's a gap or an overlap between the two sides. So if I go back to the fillet tool, and I'll just make that G2, and I'll need a much smaller size, so maybe 50. And here where we've got an overlap, depending on which side of the line you choose, you can see these dots which tell us which side the fillet's going to be built on. So if I undo that, and I went on this side, then, it's failed, and that's because the fillet value is too large. So if I make that smaller, then it'll build here. So if I gradually make that bigger, you can see that it starts to run out of curve, and that's when it'll fail. So if I come over here, if I do a fillet that's too small for the gap and try to build from there to there, again it fails. So I'll put that back up to 60, which is what we had before. So this curvature fillet is starting at the same point as the tangent one, but because it has this softer lead in, it's pushing out the center point. So I've got two choices here. I can either change this value and then watch the curve until I get what I want. And so to meet the same high point, it's had to cut away a larger space. Or I can specify a center radius as being 60. So that although with a curvature fillet the radius will vary all the way along the length, at the center point it's approaching 60. And again, to achieve that, it's cut away a larger gap. Now if all these settings look a bit complex, remember that in practice what we tend to do is just play with the sliders and just watch the shape of the curve and the distribution of CVs until it looks about right. So you can use that same technique to build all of the fillets around this side glass, using the canvas plane as a guide. And then we'll use these to build surfaces in the next tutorial. So the two main benefits of the curve fillet tool are that you can choose your continuity levels, and it works on curves that are shaped in 3D space. And if you'd like more information on the terminology and the settings, then take a look at the Continuity One Theory Builder.